let's actually go around the room and introduce everybody. So, Clint and Miles, if you wouldn't mind introducing yourselves, because you guys are new to the group.
Okay, so I'm Clint. I'm an electronic technician here at the University of Cape Town. And yeah, I'm working on all the electronics to interface with all the X chips for this interesting project. Yeah.
All right. Hi, I'm Miles. I'm here representing the N Lab from University of Cape Town. So Andy and Tanya are my supervisors. I'm a PhD student just starting now. And we're working on some radiation detectors for MaxIQ and this
Fantastic.
project.
Great, Miles. Thank you so much. Susan, would you and the team like to go ahead and introduce yourselves from Massachusetts?
Yes, my name is Susan Ewens. I'm a vocational engineering technology instructor with Greater Lowell Technical High School in Massachusetts in the United States. And these are some of my team members that are going to be working on the project. You want to introduce yourselves?
I'm Aiden Simmons. I am a junior over at Greater Lowell Technical High School.
My name is Miguel. I'm also a junior at Greater Lowell. My name is Marcus Fetchner. I'm also a junior here at Greater Lowell Engineering. My name is Gerard Tao. I'm also a junior here at Greater Lowell Tech.
Fantastic. Thank you so much. Mike, I see you have been able to join us. If you wouldn't mind introducing yourself to the team. And what time is it there in Shanghai?
Hey, Judy, it's 8 p.m. here. My introduction will be brief because Ange is sick and I'm currently trying to feed the baby. But I'm Mike. I'm a staff engineer at Princeton University, and I work on NASA projects, both large and small, like this one. So I'm looking forward to supporting everybody.
Great. Mark, thank you very much. And thanks so much for joining us. I know you're actually on a family vacation at the moment. So that's absolutely wonderful. And Jim Gorman, how about you?
Yeah, I'm Jim Gorman from Nipmuc Regional High School. We did NASA HAB last year, so looking forward to this year's turn.
Great. And Jim, I was actually just wondering if maybe over the next few weeks, if you could share with us your experience as a teacher and leading the team. Susan's available to go this year and possibly take some of her students. So I would really like you to be able to share some of the logistics challenges, what worked for you, what didn't work for you, and what the experience was like, what's worth seeing, maybe what isn't worth seeing, all of that kind of thing.
Sure.
And I'm not wanting you to do that today. I thought let's schedule that. I want to give you a little bit of time to be able to think about it, etc. Alex, how about you?
I'm Alex Pachowski. I'm the chair of the Applied Science and Engineering Department at Trinity and also the Chief Technology Officer. I would have kids here, again, like I said, I jumped in, except that we're finishing APs and just starting our regular final exams. So I'll actually have students hopefully on the next couple of calls because they're always, we always keep missing each other because of the schedule. So, but I'm looking, this will be our first time for the high altitude balloon because we jumped in just as it had all been settled last time. So
absolutely. And Alex, I'm very happy for us to have a workshop with your students when it suits them, because we are acutely aware that it is exam time in the US.
No, not a problem. We've been going through a bunch of stuff, and we're doing our transitioning from our seniors that are on the project to juniors and inviting new kids on. So we'll have another group, and I'm trying to get some of the ones that are coming with me in July to see if I can entice one or two of them so that we can sort of correlate the project while we're there later this year. But that's
great.
Fun.
Absolutely. When Alex talks about when we are there, He's actually coming to Cape Town in South Africa. So
Yeah, we'll be there in late July.
yeah, absolutely. Please bring a waterproof hoodie. Umbrellas don't work here because when it rains, the wind also blows.
No, when we visited last year, I was one of the few people that was prepared. I had waterproof jackets and yeah, I was ready. So we'll be good. But I'm not expecting it to be a complete week of rain again. It's
Okay.
just, but again, you're not that far off from Florida. You have to be ready for rain at a moment's notice. So we're good.
That's it. Absolutely. Absolutely. Amanda, how about you? Would you like to introduce yourself?
Yes, good morning. I apologize. I am driving my kids to school at the moment. But my name is Amanda Kruger. I am the assistant principal at our school, and I also lead our gifted and talented program on our campus. And the students working on this project are 7th graders. One of them, including my daughter, who is sitting next to me holding my coffee, so I did not spill it all over myself. But we are very excited about this project, and we can't wait to get started.
Fantastic. Thank you so much. And yeah, please drive safely and have a wonderful Monday. Leanne, how about you, if you wouldn't mind introducing yourself?
Hi, so I'm Leanne Steinberg, Head of Innovation at Parklands College. So yeah, like Alex, we are just about to start exams, so I don't have any learners with us. They are getting their last little bit of tuition in before they start. But we're also looking forward to this experiment. We've got grades 10, 11, and 12 that are participating. And our grade 12s are quite excited to actually have the opportunity to do 2 projects with you, Judy and Bianca.
Great. Yeah, thank you, Leanne. Also, the students were able to participate very much at the last minute in December last year on an ASRI test launch. And amazingly, we actually got the payload back with the data on the SD card. It had been washed up after a few weeks. It washed up from the ocean, from the Indian Ocean, and everything was intact. And there was data on the SD card that could be recovered. This is really very interesting.
That was quite exciting.
Yeah, absolutely. It's always great to see that data. It's like, finding something feels like finding something in some kind of time capsule and, breaking it open and being able to read that data. Fantastic. So everybody is with us. Amet was planning to join us, but I don't think she's able to. She did the what is it called, Jim? The weightless flight last week. She actually sent us some videos, so that was great. And I think it's next week, probably before the end of this month, she's going to be taking her students' experiments actually into space on a Blue Origin flight. So she was able to secure some sponsorship. So she's going to be going on the Blue Origin flight before the end of May, but we're not sure exactly what the date is yet. Wonderful. So let me share my screen and let's go through it. So this is the onboarding session for the high altitude balloon mission with NASA Goddard. And every year, NASA Goddard has a high altitude balloon project that flies from Fort Sumner in New Mexico. The date they always use for the launch is the 15th of August, but that can slip even sometimes up to 2 weeks, which is very much weather dependent. So what are we going to have a look at today? We're going to have a look at the mission parameters. We'll have a look at some dates and deadlines as well as the next steps. So I actually have that engineering model with me right here. So this is the engineering model that we put together for last year's flight. the package that we ended up sending to Jim didn't look like this. It had X chips in it, and it was a similar configuration, but we Bjarke had to make some changes to the power solution. But really what it is that everybody's going to use the extended core, which you have with you. And there you can fly standard X chips, you can use the prototype boards to develop your own sensors and your own payload. And what's really important is that you make sure that your data is saved to your SD card, because that is how the data is going to be recovered. We don't have any downlink at all with this project, so you are 100% reliant on the data being saved to your SD card. So what we are going to provide this year is we're going to provide the power. Actually, the power is being provided to us by NASA, and then we're going to be providing the power to all of the payloads. And we're also going to be able to collect our own GPS data this year, which is great, because last year the data there were a few gaps and things like that. It was very difficult to line up with the data. Of course, the launch is being arranged, and then the payload return. NASA is always able to recover these payloads. And so what I'm going to do now is I'm going to go to this next. No, I'm not going to go to this next slide. I'm actually going to stop sharing. So let's have a discussion now on what exactly it is. And Bjarke, maybe if you want to share anything in terms of the parameters. So what I'm doing is that I'm holding up now, and I'm just gonna pin my camera so that it's on the video, on the recording. So this is the core that we're using. It's what we refer to as the extended core, or the CWV, with the standard ESP32 module, the camera connector, the SD card interface, and then the 20-pin connector. So just make sure that you're using that core and not this smaller ISS core. This ISS core is meant to be your engineering model for if you're participating in the ISS project, but you will have received your extended core for the high altitude balloon project. So does anybody want to come in and just have a chat about what they are going to be putting on their payload? Clint, should we begin with you actually?
Yeah, so I think Miles actually made a little presentation that he wants to do, so I'll hand over to him on that one.
Perfect.
Yeah, sure.
Thank you.
Miles,
you may share your screen with pleasure.
All right. Sure. I've just co-opted a presentation that Andy made for Parklands. So some of this isn't necessarily going to be relevant, but I will, how do I do this again? There we go. And oh goodness.
There we go.
There we go. You can see that.
Great. Perfect. Thank you.
All right. So the context behind the payload that we would like to send is radiation, and specifically radiation at flight altitudes. So this is produced by a number of processes, namely cosmic rays incident on the atmosphere, and they produce gamma rays, neutrons, and other radiation. This is generally coming from the sun. I'll skip over some of this stuff. And what we, hold on. There we go. What we're concerned with is that there's a fairly high proportion of the dose that you receive at flight altitudes that is a result of neutron radiation. We're in collaboration with a citizen science project called Cosmic on Air, where we're trying to make available a number of detectors that you can use as a citizen and take them on flights, and they will record the dose received, and then those data can be uploaded to a database and analyzed by scientists. On my video, you might be able to see. Oh, there's the blur going on. Anyway, I have a detector here it's called a SafeCast, and this is a gamma ray detector. And these work really well, and we're able to use them. But what we don't have is a neutron detector, and so my PhD is the development of this detector, and this project is a great opportunity for us to test some technology. Let's go over here. There we go. So this is the detector that I was just holding up. It's called a SafeCast, and this measures gamma rays. And what we've done is we've managed to, modifying this to fit onto one of your MaxIQ development boards. So here's a picture of the concept. We take this Geiger detector, this pancake, and the pulse processing board, and then this will send a logic pulse to the MaxIQ board, which can log number of counts per time period, and save that to the SD card. What we're also interested in doing, because that one just detects gamma rays, we'd also like to detect neutrons, and so we've got this detector that we're putting together that has it's a piece of plastic that is sensitive to neutrons and gamma rays, and it will give us counts per some time interval in the same way as the other one, but for neutrons and gamma rays, and we can do some data analysis to work out the difference there. Yeah, Judy, I'm not sure what else you'd like to me to mention here, if there's anything timeline or
That's great. Miles, that's
Perfect.
great. Thank you very much, because this data is going to be interesting for everybody.
These look like awesome experiments.
Yeah.
This is a picture currently of where we are. So we're busy. We're almost there in terms of hardware development. Oh, and importantly, we're working with Parkland's college, and they'll be helping us with the interface between our detector and the MaxIQ board, because that's something that we don't have much experience with. Yeah.
Okay, that's absolutely fantastic.
So let me
Wonderful. Miles, thank you very much. And
Yeah.
I think that Montana State University is also going to be doing something in terms of radiation sensors. So I think that's going to be really great, because then we've got a lot of data to compare. And just one thought that I had was perhaps it's an idea as well to send some of those sensors with the boat that goes to Antarctica from Cape Town, because what it does is it goes via the various islands like Marion Island, etc. And what it does is it actually goes through that area of the Pacific anomaly. What is it called again, Bianca?
The South Atlantic anomaly.
The South Pacific anomaly.
South Atlantic.
Oh no, South Atlantic. South Atlantic
yes,
anomaly.
exactly. I mean, I'm just like
outside
I
of
may as well
the
be on another planet. I'm talking about the wrong ocean. So yes, South Atlantic anomaly, where I think the ozone layers, whatever, something is thin there and more radiation gets through. So I think that could be quite a nice idea to look at. I do know that boat sails every November to change the crew on Antarctica. So let's see if we can get it onto that boat. Mike Galvin, I know that you are holding a child in one hand and food in the other hand, but maybe if you just wanted to discuss your experiments.
Sure. We're just flying mostly standard X chips. We have the new kit on there. We have two payloads. They both have some of the new standard X chips, weather sensors, pressure, temperature, accelerometers, and then I think we flew some of the older X chips, including 9 degree of freedom IMUs. And we have one of the GPS X chips on there, and we think we successfully set it into high altitude mode. So we're interested to see if it reads all the way through the altitude range to get our own independent GPS data.
Right.
And then we got the camera to work also. So we're sending the camera just as a flying lead, and hoping Bjarke can point it towards something interesting.
Right. Excellent. Thank you so much.
If I can
Yes.
just come in here.
Of course.
So camera-wise, so we got permission to fly cameras with NASA. So they're pointing towards the horizon. So we're setting
take
up. Sorry, you take it. We can't point it towards the ground. Then they get very nervous because it flies over military installations. And we could point it towards the sky, but that's actually only interesting when the balloon pops, and we might not see that. So it goes towards the horizon.
Can you
think for
sneak
some
a
of the
mirror in there?
yeah, okay, that's a way of doing it.
Like almost like if you were to put it on a selfie stick. Do you want it facing backwards?
I want to look down at the stuff that we're not supposed to look down at.
No, sorry, not going to happen. I'm not going to be ostracized for 3 generations up and down by the NASA team, if you don't mind. Jim, I was wondering, what are you going to be doing this year that's going to be different from last year?
Yeah, well, we're gonna put a GPS, but since Princeton's gonna do that, we'll just get their data. But we were gonna do the
I suggest you go with yours also, because they're quite finicky, and sometimes ours just doesn't acquire satellites and it just writes nothing. So is more GPS the merrier.
Okay, so maybe we'll very good. Now, one thing with that, we're going to have to, thinking ahead, because we have GPS signal on there, they're going to want us to run on the day before, essentially. You're going to have to be at the testing for that to make sure that it's not interfering with other things. That's the only hiccup that could be if the GPS interferes with other stuff.
Bjarke, please come in there.
Oh,
Yeah, I'm on mute. Sorry. So, I mean, we talked to them about it. They have no problem that we have a GPS on. So we asked NASA about the parachutes. Sorry, not parachute, a camera, and we asked them about the GPS, and they're happy we put GPS on board because it's just a receiver.
Perfect.
And then we actually also changing the power system. So we are now getting power from the gondola. So we don't have to provide our own power. So, I mean, we have to do a power interface, which is a little tricky because we get like, I think it's 27 volts or something like that. But we're doing a power module for that. So we don't have to worry about that in the future. But regarding the GPS, there shouldn't be any problem. So yeah,
it will just require you to be. The power will require you to be there too for that Tuesday. Whatever.
Yeah. So because we are getting power from them, we don't have to worry about recharge or any of that kind of stuff.
Yeah. Oh, that's real.
So that's the reason why we want to do it that way. We don't have to consider whether the battery getting cold or all that kind of stuff. They're providing the power, and we just have to be able to plug it in. So that's it.
Perfect. Yep. So so we'll put the GPS definitely on there. We have a kind of the same thing we're running on the ISS one, the ICU, which gets the gyroscope and the acceleration data. And we were going to put on the radiation chip, not radiation, but magnetometer on there too, as well.
What about flying that same sensor again that you flew last year?
Yeah, well, you had said what were we doing different, so I just focused on the difference.
Okay.
But yes, yep. We'll do that sensor again to see. Nice comparison, we thought.
Great. Susan, how about from your students?
Okay, so my students are first going to see if they can get the camera on their payload, but they've been, because this is a new set of students, the seniors are since graduating. This is their last week with me, the seniors. They're thinking of putting their own unique project. One idea that they've been talking about is maybe recording sound, like maybe have a sound that their project would send out and then have a recorder on it. We have to look at the feasibility with that, but that's one of the ideas that they're thinking about. They'll be able to finalize their idea for the project this week. Do you think that idea is feasible with your technology?
It definitely is feasible. We actually did develop a sound pressure sensor chip for Virginia, for the Virginia Space Ground Consortium. What they wanted to do is they wanted to measure sonic thumps. NASA's developed a plane which can fly supersonic, but it doesn't have a sonic boom. It's more of a thump, so that it can actually fly faster than the speed of sound over land. So the schools in Virginia have received that sound pressure sensor, and it does actually work with our ecosystem because Bjarke designed it. So what we could do is we could arrange for one of those to get to you. All of them are in Virginia because we developed it specifically for the space grant there. But let me have a chat with the team. I'm sure they'd be very happy that you use that on the high altitude balloon. So yeah, it is. It's great as the sound pressure sensor, and then also in combination with the barometer, because you may want to see if there's a noise. Is that because does that also correlate with some kind of increase in atmospheric pressure on a very like a localized perspective? And then also it'll be good to compare that with the GPS data so you know exactly where that happened. That could be really interesting because the balloon is going to burst. Or otherwise, maybe what they'll do is maybe they'll have a controlled descent where they actually start letting out the helium. And I'm sure you would pick that up. So that could be a really interesting sensor to use. Bjarke, what do you think?
Excellent.
Yeah, so we just have to be careful about, because remember the sensor communicates using some of the connectors that are being used for other stuff also. So so on this board here, the way we program this board is that we're using the PPU. And those connectors on the PPU is also being used by the microphone. So if we are putting, you can program it, but then you can't use the PPU to for example, see what's happening or anything. You can't do any kind of like debugging, because you have to take the PPU out when you put the microphone in. So it's a little bit more complicated. We did it with the new CWA core, and because of that, it has the USB, and therefore it was easier to put the microphone on because we didn't have to use the PPU. So while it's technically possible, it can be somewhat a headache because you don't have any debugging possibilities. And that's because we're using this core here that don't have a USB on it.
Bjarke, does the SPL sensor just read pure decibels, or does it read a waveform?
It actually reads a waveform, and then in the code, I convert that to a decibel.
Okay, because we've routed a microphone back to your core also, but I think we had an intermediate DAC or something to convert it to I squared C somehow.
Okay,
So
okay, yeah.
So we've done it. I forget how we did it, but I have the old circuit. If anybody wants to, if we connect the dots via email, I can send a photo of the old circuit where we got a microphone back to the core.
Okay, and what did you do? The waveform or the sound pressure? The decibel?
We were trying to get a full waveform. So
okay.
My student said it worked.
Okay, but so you probably the converter using an ADC or something like that.
Yeah, I think so.
Yeah. So the microphone we're using is a I square S. So
yeah,
it's a
same
digital microphone. So
it
was the
same.
same you had?
Yeah, but I think we found like an I squared S to I squared C converter or something. But
oh, okay.
I'm making things up right now, so I should do this by email instead.
Yeah, that would be great. Let me see what you have. So when we did it, we took the I square S signal because it's 3 pins, and then we fed them in because we didn't use RX and TX on the new core here, and we had like an IO, and we only needed 3 pins, so therefore we fed them into those 3 pins, and that worked great. But that was because it was meant for a project where they were gonna use this one here, not that we were thinking about that we were gonna use with this. But I mean, if you have a project, then please share it, and I can see how it's been done, Judy. But I don't think it's going to be ready for this time around.
Okay, I'm going to throw a really crazy idea through, and that is maybe we use this core for that experiment. We use this core only for mechanical and power, and we actually use this new ESP32S3 with the SD card connected to the 20-pin connector and the sound pressure sensor. So we actually use this as the core and the SD card with this SD card. I don't know. And this is only here mechanically and for power.
Yeah.
Let's chat
idea.
about it. Let's see. Let's think about it. Okay, let's think about it. Great. Alex.
I've got a sorry.
Yes, please. Clint, go for it.
Yeah, I've got a question. So I understand, if this is right, that this is all going to be exposed to the atmosphere, the temperature of the atmosphere. It's all going to be open.
Yeah.
So we know that, the higher you go, at a certain point, it gets quite cold, down to about 50, 60, minus 60 degrees. Most of this electronics is kind of spec'd at about minus 40, guaranteed to work at minus 40. Have you had any issues with the electronics kind of shutting down at minus 50, minus 60?
No, we've flown this thing here. So minus 60 happens already at 12 kilometer. And so we've done our own balloon flights at 12 kilometer, and we have hit the minus around 56 and 60, and we have had none of the electronics shutting down. Everything has been reporting data. So yeah, we have had not a single thing stopping, other than batteries stopping because of power. But if the batteries are kept warm, actually we have flown with some AA non-rechargeable lithium batteries that was rated for minus 40, and those we could also operate down to minus 55, I think it was, and that worked. But otherwise, our electronic here had worked flawlessly. We flew last year, Clint, with 4 different projects, and including project that was they also used prototype boards and things like that. And we just I haven't experienced anything that shuts down because of that. I think it's also because at that temperature, and now I'm just guessing here, but because the low pressure, somehow I don't think the coldness kind of like gets to the hardware the same way. But as I'm saying, this is just speculation from my side.
And then, I mean,
yeah.
I mean, also, if it were to go through a cloud, for instance, the humidity would be quite damp, condensation, no issues with that.
No, and we actually measured that. We have a humidity sensor, so we can measure exactly when we go through clouds. We can also calculate the cloud levels beforehand. I actually look it up, and we can see we survived going through clouds without any problem.
Okay,
So
that's good.
Yeah. Jim, do you have anything you want to add from your flights, or maybe from talking to the NASA people on site?
Yeah, no, ours worked. It just, maxed out the sensors. That's all. They still kept recording everything. It just maxed out. And once the levels fell, within range, they came back right back down. So we didn't have any issue.
Okay, no, that's good. Thanks.
Yeah.
Great. Alex, are you going to be doing anything apart from vanilla X chips?
Well, we're definitely going to run the camera. We're going to try some of the X chips. I like the idea of the GPS, so I'm going to see if I can get one of my more advanced students to do that. And they were going to actually try. They were in because of our work for the ISS piece, Parkland's work, really. We were going to try and they were looking at magnetometer for expanding out. So we'll see if we can get that working. I don't know if we'll be as fancy and crazy as everybody else, but I'll keep going slow and steady, and we'll be the reference point for everybody else. And we just got to make sure that my camera and Michael's camera point in different directions so we get good views. There we go. One goes east, one goes west to the horizon. So you see, see us coming and going. So.
That's great. And Amanda, from your side?
We're going to be using mostly the standard X chips. We are going to endeavor in adding the camera. I know at one point y'all were talking about the camera that's the most compatible. I did have a question about what that was so that we could start looking at getting that ordered. But yes, we would like to add a camera, and if we get that to work, we may look into something else, but that is our plan. Our students are about to go off on summer break, so we're going to be scheduling meetings, and whoever can come will be coming in and out working on it. So
excellent, fantastic. Wonderful. So what I'd like to do now, if you don't mind, is if I may share my screen again. Let's have a look at the schedule. So we had no confirmed takers for the second workshop today, because what we found was that there were two people who could only make the 8 a.m. Eastern Standard Time. Everybody else was pretty flexible. We'll try again with the 10 a.m. Eastern Standard Time workshop on June 2nd. And then we'll have a final workshop mid-June. And then we really need everybody to ship their payloads by end of June, so that we can work on everything, integrate everything during July, and have it ready for August. And we will expect to have a follow-up workshop once we have our data back. That will be during September. So we'll receive the payloads back when it lands, and it gets shipped from Fort Sumner. But everybody needs a little bit of time to analyze their data, etc. You also all have access to my calendar. have that calendar link, and that works into the future, for perpetuity. So if you really just want to schedule some time with me, if you want me to get Bianca on the call, please just do so. We're here for you at the drop of a hat. And so the next steps are really actually around deciding what you're going to do and to start coding to get that data saved to the SD card. Last year, Jim Gorman and his team, actually, I think it was the year before last, Jim, because I think it was originally for that Blue Shift engine test, wasn't it? That you did some code for the extended core to save the data on the SD card. So we do have something that you can begin with and then start using.